Hello, and welcome to ALEK's walkthrough video number 2. I'm Professor Robert McKeown, and I'm very happy that you decided to check out my video. Today we're going to take a closer look at equations, and we're also going to learn about mathematical notation. We can think of mathematical notation as a language, just like English or Mandarin or French is a language. It's the language of mathematics. And so I hope by the end of today's video, or perhaps after a little bit of practice, you'll become comfortable translating English into math notation and translating math notation back into English. Now, I'm not going to try and cover every single topic in ALEK's. I'm just going to cover the topics that I feel are most helpful to you, either because they're important or because they're fundamental, and by learning them it's easy to go further into more detail. As usual with these videos, what I expect from you, I expect you to have your pencil, paper. You can print out the slides. If you have lots of devices, maybe you want to even write your notes on a second device, on a tablet or something like that. Whatever works for you, but I highly recommend you work along with the problems or try the problem first and then watch the video. So if you're ready, I'm ready. Mathematics has its own language of symbols. These symbols give you instructions and describe some of the mathematical values and variables that you'll be working with. Like any language, we can translate it into English. If you look at the slide in front of you, you can see some mathematical symbols in the left column, how we would, the English expression, so how we would actually say these things. And then I've given you a little bit of their meaning. And so I want to take a few moments to explain to you interval and set notation that'll help you answer some of the questions in ALEK's. Take a moment and familiarize yourself with the table. Looking at the example, I can write this mathematical symbol in English, which I'm going to do for you. Now, this is an interval. And 4 is the low point, or the lowest value. And the interval runs up to its largest value. And since it really has no upper limit, there is no largest value, we represent that concept with the infinity symbol. Right? So infinity symbols are not numbers. Infinity symbol represents a concept. No upper limit on this interval. The next thing I want you to notice is that we have a square bracket. A square bracket represents a closed bracket, and so what does this mean? This means the interval includes the value 4. So in English, X is in, right? That's our in symbol. The interval 4 to infinity. where infinity is representing a concept that there's no upper limit. Whatever number, however big a number you can imagine, x can take on that value. There's one more thing I'd like to show you, and that's an alternative way of expressing this thing mathematically. And so I could write x is greater than and equal to, or I should say or equal to, x is greater than or equal to 4. And if I write that, these things are equivalent. So that's an alternative way of writing it, and that's going to come in handy when you look at the problems on ALEKs, and when they ask you to go from an expression like x is greater than or equal to 4 to writing the set or interval notation. Now let's go to the next slide, and let's take a look at the next example. So the table is the same, but the example down here is a little bit different. So let's go through this example. Now, the variable v is in the interval from -5 to -2. Now, I said that, but what about the round brackets and the square brackets? So now, what values can b take on? Well, we've got a round bracket, and so v must be larger than -5. And we've got a square bracket over here, and so v has to be less than or equal to -2. Now here I am on ALEKs, and so we have a question from ALEKs. It says solve the compound inequality. And so we're given two equations this time. Both equations have x as the unknown variable. And then we're told write the solution in interval notation. If there is no solution to these two inequalities, enter that funny looking 0 or that circle with a line through it, which is our null set, also sometimes called the empty set. Now you are going to work on this problem on a piece of paper. I'm going to take us back to our slides. And so here we are in the slides, and we want to write the solution to this in interval notation. So we'll start with this equation on the left-hand side. I've got 3x. I'll subtract 6 off both sides of the equation. So I'll just write that as we have x must be less than 6. Now let's take a look at our other expression. So I see I've got a 2x minus 2 on the left-hand side. I'm going to add 2 to both sides of the equation. So I'm going to have 2x is less than or equal to -8 plus 2. So that gives me 2x is less than or equal to -6. And x is less than or equal to, dividing both sides of the equation by 2, I get -3. Now the question had a very important instruction, that I have ignored so far, and that is right here. So the question is saying that either the question on the left is correct or true, and the question on the right is correct and true. So x must be less than 6, or it must be less than and equal to -3. So I'll draw a real number line, and I'm going to have 6 over here and negative 3 over there. Now, if I want to start with this equation, now I'm going to write the equation over here, and I'll write this one over here as well. And so you can see that if x is less than 6, the inequality is satisfied. But I'm going to draw a circle, an empty circle here to represent that this is open. And that's an analogy. You can think of that as that open bracket that we saw previously. Then over here, x can be equal to negative 3, so I'm going to draw a solid dot to represent it as being closed. So a circle or a dot with a hollow in the middle, that's open. Solid dot's going to be closed. Now we can go over to ALEKS and solve the question, or I should say put the answer. ALEKS. Before we move over to ALEKS though, maybe I should point out to you that notice that if x is less than or equal to 3, then x is also less than 6. And since either one of these inequalities has to hold, the correct answer is going to be x must be less than 6. And so x is in the set negative infinity to 6, with a round bracket to represent that x cannot take on the value of 6. It's an open set. It can't take on the value 6. So here we are in ALEKS. We have the same question that we were given before. What is the interval here that we're looking for? Well, we know that it's going to be rounded brackets, and the value of x can be as low a number as you can imagine. So I'm going to put a negative infinity symbol in there, and the maximum value it can take on is something just a little bit less than 6. And so we represent, or I should say a little bit less than, oh no, sorry, that was 6. Any value less than 6. Now I'll check my answer, and we got the correct answer on ALEKS. The interval of x is going to be between negative infinity and 6, but it cannot take on the value 6, so we have the rounded bracket.